Hey everyone, welcome to another math lesson from the Apex Institute of Mathematics. My name is Akin and we're going to be looking at some Behrens questions today. Of course, this is the first video that I'm going to be posting on my new channel. I have another YouTube channel to which I usually post on, and of course there are many contents on that channel there, but for the most part for today's session we're going to be looking at some Behrens questions. A few of my students did send me these questions and they asked me for some guidance in the thought process of working out these questions. So of course, if this is the first time here on my new channel, please be sure to subscribe, like and share. And so let's get this show on the road. So we're going to be jumping, we're going to be looking at about 5 questions thereabout. So let's begin and let's look at the thought process throughout these questions. Now, the prerequisite for being very competent at the Behrens topic in the CXC syllabus is that you have to have knowledge of the Pythagoras theorem. You have to also have knowledge of using the trig ratios, and most importantly for this video, you have to have a very good knowledge on what the sine rule and the cosine rule is. So let's get right into it. So for this first question here, we're looking at the diagram below shows straight, is that roads? Yes, I believe that is. The diagram below shows straight roads connecting the towns L, M and N, L, M, N and R. LR is 18, which as you can see right here, L to R is 18. LN is 12, so that's L to N is 12. Good. MN is 10, M to N is 10. Angle RLN, the angle, guys, is located at the letter that is in the middle. So the angle RLN is 25, which you can clearly see here. And the angle LMN, the angle is located at M, is 88. So that's the only instruction that we have received so far. So our first question here would be to calculate the angle MLN. So we're looking for the angle that is located here at L, which is indeed right here. Okay, so that's what we want to try to find. So how are we going to get that angle now, guys? We're going to pretty much just look at the triangle that is at the top. So that is triangle LMN. Let's have a look at that triangle. It's a regular triangle. Okay, so that tells me that if I'm dealing with a regular triangle, usually cosine rule or sine rule usually plays an important role in this. Now, in order for us to find an angle using the cosine rule, all 3 sides of the triangle that the angle is located in must be known or given. All right, in this case we do not have all 3 sides, so we are going to be forced to use the sine rule for this. All right, and so the sine rule here is that it is A over the sine of the angle facing A, which is going to be equal to B over the sine of the angle facing B. So the small letters represents the length of the sides, and the large letters, the capital letters, represent the size of the angles facing these sides. So what I'm going to do here is just assign the letter A to the side. Okay, so I'm going to assign the letter A to being 10, and so the angle facing 10 becomes capital A. And of course the angle, let's see here, B, give 12B, so the angle facing B is going to be capital B here. Okay, so with that said, then let's just insert our values here. So that's 10 divided by the sine of the angle facing 10, and so that angle is what we want to try to find. So that would be angle MLN, which is what we're trying to find, MLN. All right, so that's sine of angle MLN, and that's going to be now equal to 12 over the sine of the angle facing 12. that would be 88. So I hope you guys have your calculators out with me. That's going to be 10 divided by the sine of angle MLN, and that's going to be equal to 12 divided by sine of 88. Ensure that your calculator is in degree mode, guys. So that's 0.999. all right, we're going to proceed now to say 12 divided by 0.999, and that's going to be equal to, therefore we're going to get up here. That's going to be 10 divided by the sine of angle MLN, and that's going to be equal to 12 divided by 0.999 is actually 12.01. okay, so if we cross multiply here now, all right, after cross multiplying, then the sine of the angle MLN is going to be equal to 10 divided by 12.01. okay, all right, so 10 divided by 12.01, and that's going to give us here 0.8326. okay, gotcha. And that's going to be equal to the sine of angle MLN. So if we actually want to find the angle LN, that's going to be equal to the arc sine, that is sine inverse 0.8326. and if we insert shift on our calculator and hit the sine function 0.8326, we get a result here that angle MLN is equal to 56 degrees approximately. okay, and that is how we work out that particular question, guys. okay, so what I do recommend for you here is that after finding, all right, so after finding the angle, all right, you want to try to insert that angle where its location is, so it gives the diagram a little bit more life in terms of maybe we might have to use it a bit later. all right, so that takes care of example number 1. Well, not example number 1, part 1 of this question. Let's look at part 2, where we are required to calculate the distance NR. So that's the distance NR from here to here. all right, so in order for us to do this now, guys, you can clearly see that the cosine rule is applicable here, because we have two sides. That is, we have this side here and this side here, and we have the angle made by the two sides. So that criteria is the criteria for cosine rule. all right, and so what we're going to do is just get down to the bottom here. all right, so this is going to be part 2, and the cosine rule is that c squared is equal to a squared plus b squared minus 2 multiplied by the product of the two sides times the cosine of the angle between the two sides. okay, in this case c will represent the side that we're trying to find, and in this case it is nr. So that's going to be nr squared, and that's going to be equal to the other two sides, which is 12 and 18 respectively. So that is 12 squared plus 18 squared minus 2 times 12 times 18 multiplied by the cosine of the angle between the two sides, which in this case it is 25. okay, all right, so if you have your calculators out with me, guys, you should know that 12 squared is 144 and 18 squared is 324. And if we multiply 2 times 12 times 18, we're going to get 32. And so the cosine, I should say the cosine of 25 degrees, ensure your calculator is in degree mode. All right, so that's going to be 0.906. I can put another decimal place here, makes my answer a little bit more accurate. okay, so that's nr squared, and that's going to be equal to 144 okay, plus 324, that's going to give us 468, and we're going to take the result of 432 multiplied by 0.9063, and we're going to get 391.52. Subtracting both these numbers, that's 468 minus 391.52. that results to be 76.48. that's going to result in being NR squared, and so NR will therefore be equal to the root of 76.48, which results in our length of NR being equal to 8.74 or 8.7. Is this centimeter? Is it? It is kilometer. Okay, so it's 8.7 kilometers approximately, and that is the result of part 2 here. Okay, not a bad question at all. If you have knowledge of the cosine rule, it should not be a problem here. All right, and so we just go right ahead now and proceed to insert our measurement right here. That's 8.7 meter. Beautiful. All right, so let's move on now to question number 3, the last part in this particular question. We are looking to determine the bearing of town R from town L. Now, one of the primary rules or the primary knowledge that one needs to know when it comes to calculating bearings or determining the bearing of point A from point B is, number one, a north line needs to be established at the location coming after the word from. So since we are going to be trying to find the bearing of town R from town L, we need to therefore insert a north line at town L. And fortunate for us, it has already been established. And so rule number 2 is that a bearing is measured in a clockwise direction, that is making an arc into the direction clockwise to the line that is leading you to the town or to the location, which in this case is town R. So if you were to start from the north line here and basically come around like this, okay, all right, just a second, okay, good, got you. So come around like this, guys. This is the line that's leading us to town R here. So it's all of this angle that we're looking for, and fortunate for us, we just found the 56 degrees and they already gave us the 50 and the 25. So therefore, in summary, we can safely say then that the bearing is therefore equal to 25 plus 56. Is that what we had? Plus, is that 50? Right, so 50 plus 56 plus 25, and that's going to give us a complete bearing here of 131 degrees. And so that pretty much takes care of question number 1 from this series of bearings question. All right, that took us about 15 minutes, and it does take some practice to get into it. So let's move on now to another question here, which is going to have a little bit more challenge to it. All right, so here we go, guys. So a ship leaves port P and it travels to port Q, where port Q is kilometers away, and it is on a bearing of 121 degrees. From Q, which then is now at, the ship then travels to another port, which is now called port R, where port R is on a bearing of 320 degrees. And the location of R is going to be based on the fact that the bearing of R from P is 25 degrees. The following asks us to draw carefully labeled diagram representing the journey of the ship determine the bearing of P from R, and we're to calculate, giving your answer to 2 decimal places, the distance between P and R. Tough question, guys, but it is very, very doable. So let's get right into it here and start by constructing our diagram. So the ship is leaving port P and it's heading in the direction of port Q. So the first thing we want to do here, guys, is that we actually want to place a point that's going to represent port P. All right, that's port P. As long as the object is moving, then we are going to need to establish what is known as our north line here. Okay, that's our north line. Once that has been established, then we now begin to construct our direction to where Q is. Now Q is 50 kilometers away on a bearing of 121, so we're going to need some what I call guidelines. Okay, I'm just going to remove this for a moment. So I'm going to use my guideline here. I'm going to use the 90-degree guideline. I'm going to use it in broken lines for you here, guys. Okay, all right, so let's do it here. Okay, so I'm going to use a 90-degree guideline here. And I'm also going to need a 180-degree guideline here, because the bearing of 121 is going to be located somewhere between 90 degrees and somewhere between 180 degrees. So we're definitely going to need that. Now, in between 90 and 180, you're going to find 135. So by proper estimation, 121 degrees is closer to, let's see here, it is going to be closer to 90 than it is to 180. So I'm going to estimate that the ship is going somewhere in this direction here. All right, and so what I'm going to do is that I'm going to place my point here, and we said earlier that this is actually port P, and so this is now going to be port Q down here. All right, beautiful. The next part of the question here, so we've finished with this part here, guys. Okay, let's insert our 50 kilometers on the line here. Okay, and so the next part says down from Q, which is where we are now at, the ship is then going to be traveling to port R on a bearing of 320. So the ship is going to be moving again, which means that we're going to need to establish a new north line. All right, so here we go, new north line. All right, and so remember that a bearing is measured in a clockwise direction, so we're going to need a couple of guidelines here. I don't have enough space for you to clearly see the 90 degrees going to the right, but here we go, I'm going to do it regardless. I really need a bit more space, more in the center, but here is my 90 degree there in that direction. All right, I'm not going to be on that side anyways. I'm going to have my 180 degrees going south. Okay, here we go. That's my 180 degrees, and so I'm going to go here. I'm going to need my 270 degrees here. All right, and then now I know that this is 180 down here, and this is actually going to be, let's say here, 270. So I know for certain, all right, we might need to redraw this diagram, guys. We're running out of space. Okay, so let's just take a moment and redraw the entire diagram. I do apologize, just running out of a bit of space here. So let's go more towards the right. Let's start over. there we go, guys. All right, so we're back. All right, we have a little bit more space. So what we're going to be doing here now is that we're going to be inserting our bearing of 121. Okay, so the bearing of 121 is going to be located here. All of this is going to be 121. Okay, so 121 degrees. And so that bearing runs from here to here. I always encourage my students to find any minor angle that might be located in the diagram. And when I talk about minor angle, I'm talking about taking our estimated angle of 90 degrees here from our major bearing. And so we always get this small angle on the inside. So we should be able to, let's say, label that here, 90 from 121. We are going to get a total of 31 degrees in this little section here. Alright, that might be useful later on. Next, what we're going to be doing next is we're going to be looking at going on to the second section here. So now we're going to get a chance to move on now to this section here. It says from Q the ship is going to be traveling to port R on a bearing of 320. So we need to now establish a new north line. And so we need some guidelines now to get us to the 320. So we're going to start off with our basic 90 degree guideline here. We're going to go to our 180. Then we're going to go to our 270. 320 is far way bigger than 270. Let's insert those 90 degrees. (180 degrees). 270 degrees. And so 320 in between 270 and 0, or what would say 360 degrees, would find 315. So we can almost estimate that our port R is going to be in between the 270 and the 0 degrees here. So approximately going through the center here. Okay, so somewhere here, but we don't know exactly where R is. We don't know exactly where R is because we only know the distance. Actually, we do not know the distance. All right, we just know that it's on a bearing of 320. So we don't know how long this line is. We don't know whether to stop here or to go out further or to even stop here. We don't know the distance. And we're not drawing this thing to scale, so the information that's going to guide us to our stopping point. And that information here comes where it says that given that the bearing of R from P, we're going to be moving from R, we're going to be moving from P in order to establish where R is, then that literally means now that we need to establish this bearing. So we already have a north line at P here. And so we're going to go to R on a bearing of 25 degrees. So we already have our guideline of 90 here. 45 is exactly between. So 25 is going to be somewhere in this direction here. Okay, just establishing. So it's going to be something like maybe, let's see here, something of this nature. Okay, something of that nature, guys. So about there, just an estimation. Alright, so about here, guys. Alright, diagram is a little bit off here. Okay, so about here. Alright, and so inside here now is going to be 25 degrees. Right in here is 25 degrees. All right, and so once the bearing of R from P meets the bearing of R from Q, then right at this position here is where we're going to find the bearing or the position of port R. Okay, all right, little bit detail, took a little bit of work, but as long as you understand the principle of drawing a bearing, it should not pose much of a huge challenge. All right, so here we go. Now we're going to go on next to, we've completed this part. We are now asked to find or to determine the bearing of P from R. P, the bearing of P from R. So again, once you're trying to find the bearing, guys, you're going to need to establish a north line. Okay, it's going up in my writing, guys, but that's okay. And so what we're looking for is this absolute bearing here, which comes from north and it comes around in this direction here. Okay, we're looking for all of that bearing. Okay, looking for all of that bearing. All right, normally when we establish a north line, it's always nice to also establish a south line, because what this will do for us is it gives us a lot more guidelines to work with. Okay, all right, good. So that should help us a little bit there. So what are we looking for now? We're looking for this entire bearing coming around like this. So let's see here, what can we do? Ooh, it is a regular triangle, so let's check to see if cosine rule can be used. No, we cannot. If you're looking for a bearing, a part of it is on the outside of the diagram and a part is on the inside, so no formula per se can be used to assist us here. Now what we can do, guys, is that we can look at this Z-shaped angle here. I'm just going to quickly sketch it for you. Look at this Z-shaped angle to get a part of it. So here we have this Z shape here. Okay, you see that Z shape, guys, right here? It forms an alternate angle because the north line and the south line actually forms a alternate angle. So in here is equal to 25 degrees. Because of the alternate angle. All right, so we have a part of it, and so we need to find this other part here. So let's write some statements. It's not all about just calculate, we have to show calculation for this. So we can say angle, let's get my black ink here for you guys. So we can say angle NPR, this is R here, so angle NPR is equal to angle, let's call this S because that's south, angle SRP, which is therefore equal to 25 degrees, and the reason for that is that they are alternate angles. So you're going to need to write that, guys, they're alternate angles. Okay, and then the other part here now, it forms another Z. So let's zoom it up for you here. It forms another Z. This is the other Z here. Here, that's the other Z. Let's do it again. South line, the line RQ, and then Q up to north forms another Z. So we know that, let's see here now, that the angle on the outside here would be equal to the angle inside here. Okay, that's a Z. So this angle can be easily formed because remember that we had a bearing of 320 degrees coming around like this. We had a bearing of 320. So we know that the complete circle would have been actually 360 degrees. So if we take the 320 from it, then we're going to get 40 degrees here. So this angle inside here is 40 degrees. which, as we already established, that this angle also is going to be 40 degrees. So what would be our statement for that? That would be that angle, it's a tough question, guys, not the easiest of questions. So that's angle, I see here, NQR is therefore equal to angle SRQ, which is therefore equal to 40 degrees. And that 40 degrees was established simply by taking the bearing of 320 from the full complete revolution, and that is how we got the 40 degrees there. And the reason why they're equal is that, again, they are alternate angles. Okay, all right, they are alternate angles. All right, good. So now the full angle inside here, now the full angle here is going to be, therefore, which is what they ask us for here, determine the bearing of R from P. Okay, a part of it, inside part here, is 40 plus 25, that's 65. And remember that, okay, well, from north here, come all the way around to this pink line here is 180 plus 25. So I don't think that we necessarily needed to find the 40 at this point, but nothing is wrong with doing a bit of extra work because it might be handy later on. So here the bearing would have been 180 degrees plus the 25, and that's going to be equal to 205 degrees. Okay, and that is how we established. So this amount of work that we did right here was not necessary for this particular question, because we basically had already found the answer once we established the z over here. So that 25, along with the fact that the south line to the north line like that, that's 180 degrees. So 80 degrees coming around like this, plus the 25 gives us the 200. It was not necessary for this. Then that's the answer for that question. Okay, we'll move on next now to finding, giving your answer to two decimal places, the distance between P and R. And this is R. So we, okay, this is P and this is R. Okay, so we need that side, P to R. And so safely you can see that the angle needed here, let's see here. So we need this side. It would be nice to know that we had this angle, because we don't have sufficient information to use cosine rule. So this is leading me along the path that we're going to need to find the an extra angle here to assist us. All right, now remember here that we have this east line here, east, along with the line PQ, along with this line Q to the 270. This forms another Z. There it is. Let me just use a different color ink here for you. So this Z here, gotta always look for these Z angles, guys. They're very helpful. That Z there, that 31 degrees that we had established earlier, which I told you, minor angles, tends to be very helpful later on. So I can safely say that this angle here is 31. All right, so this is coming around here. Let me see, from north, coming around, watch me guys, coming around to this line right here is 270 plus 31. So I can safely find this angle in here. All right, how would we go about the calculation? We would say that this angle in here is going to be equal to the full angle, which is 320 degrees, the bearing, and we're going to take away the result of 270. 270 is what's coming around here, right to this point, plus 31. So that's 320 degrees. All right, and we're going to take away, let's see, that's 301 degrees, and that's going to be working out to be 19 degrees. That's just one way of finding it, one way. Okay, 19 degrees here. All right, so what was the purpose of finding that 19 degrees there? That we need to find this side here, and we have the angle facing that side, and we also have this 50 kilometers here, and we already established the angle inside here to be 25 plus 40. So again, as I mentioned earlier, the 40 degrees that we had established, it was not necessary for question number 2, but as you can see, all the work had already been done, so we were able to establish that this full angle inside here is now 65 degrees, 40 plus 25. So we can therefore go ahead now and use the sine rule. Okay, let's go over to the next page here. All right, so that's going to be A. So that's going to be A. Pardon me, guys. That's going to be A over the sine of capital A is equal to B over the sine of capital B. All right. And so let's go back here. Let's assign some letters now. All right. So we're going to be looking at assigning. Let's see here, guys. So we're going to be assigning the letter A to the side that we want. So PR is going to be A. We're going to be assigning the letter to the side that we want to find. PR is going to be small a, so the angle facing PR is 19. So that's going to be PR over the sine of 19, and that's going to be equal to B. B is going to be the 50 kilometer, and the angle facing B is 65 degrees. So 50 kilometer over the sine of 65 degrees. Okay, that was a tough question. That's no lie. That's definitely not the easiest of question to analyze, but hopefully this video is of some aid to you here. So PR over, let's see, the sine of 19.3255, and that's equal to 50 over the sine of 65. Let's see here, we can find the sine of 65. Okay, so sine 65, that's 0.906. Okay, so now 50 divided by 0.906, that's going to be equal to the fact that PR is over 0.3255 is equal to 55.187. And if we cross multiply, PR is going to be equal to 55.187 multiplied by 0.3255. PR is equal to 17.96 kilometer. All right, that is basically how we got that answer. All right, this is indeed a very tough question, but it took some doing. As you can see, it's clearly filled up with a lot of demonstration and lots of interpretation here. Tough question. I will just end the video at this point. Feel free to start over from the beginning. Pay very close attention to the movements, the Z angles that were established in order to obtain these little tiny angles inside here. Okay, all right, and I will see you in upload part 2, where we're going to be working the other 3 questions. Okay, so do take care. Do not forget to subscribe, like, and share the content. Take care. Bye bye.